Can you yeah, okay. Can you do a slideshow? Yes, great. So hello everyone. Um, my name is Rohit and my partner Rohit. We are going to present on MSP432 series, and today we are going to talk about UART, Hello World. So yeah, can you move to next slide? Okay, so we'll start with a brief overview of MSP432. So specifically, we'll explore three widely used protocols, UART, I2C, and SPI in this brief overview. And moreover, we'll take a closer look at the EUSCI-A and EUSCI-B modules, along with their capabilities and the convenience offered by the driverlib.h library in the Code Composer Studio. So UART is a popular asynchronous serial communication protocol used for transmitting data between devices. It allows for point-to-point communication and it is known for its simplicity. What makes it even more appealing is the EUSCI_A module supporting UART with automatic baud rate detection. This feature ensures seamless communication by automatically adjusting the data transfer speed, making UART a versatile choice. In addition to UART, the EUSCIA module also supports IRDA encoding and decoding. IRDA, or Infrared Data Association, is a standard for wireless communication over short distances. With this capability, devices can communicate wirelessly using infrared signals, expanding the range of communication possibilities. So now we'll move on to SPI or Serial Peripheral Interface, whatever one calls it. So the EUSCI module supports speeds of up to 16 megabits per second. SPI is synchronous serial communication protocol commonly used for communication between microcontrollers and peripheral devices. The high-speed capability of this module ensures efficient data transfer in SPI applications. Now let's shift our focus to EUSCI B module, which supports both I2C and SPI. So I2C, or Inter-Integrated Circuit, is a multi-master, multi-slave serial communication protocol with multiple slave addressing capability. The module enhances the flexibility in I2C communication. This is crucial for scenarios where multiple devices need to communicate on the same bus. So continuing with this module, it also supports SPI with speeds up to 16 megabits per second. This dual capability of supporting both I2C and SPI makes the EUSCIB module a versatile choice for communication needs in embedded systems. So overall, the driverlib.h library in the Code Composer Studio, it simplifies the development process by providing a set of functions and macros and the abstract low-level details of communication protocol. So in conclusion, the serial communication is a vital aspect of embedded systems, and these both modules, the USCI-A and B modules, along with the driverlib.h in Code Studio, offer a powerful combination for efficient and reliable communication between devices. So whether you're working on UART, I2C, or SPI, these tools provide the flexibility and the ease of use needed for successful embedded system development. So now Rohit will take on you to the code, and yeah, over to you, Rohit.
Yeah. So now let's take a look at the UART code. Let me just quickly go to Code Composer Studio. So Code Composer Studio is what we also used last time to do the Blinky LED program. The UART program is kind of more complicated than the blinking LED one. Certainly, we use the driver lib library, as Rohit said, since it simplifies a lot of things. And then again, as he mentioned, we are using the USCI-A module. So there are like multiple USCI modules on the board. We are using a module called A0. And so we need to define that module. Like the USCI is like more like a macro definition at the start. And then since we are using this module, we need to initialize this module. Now, this can be more like an object-oriented approach wherein you have one object, which is called USCI or UART module, and inside this function UART init, you're actually setting up the attributes of this object. So in here we are first of all setting the pins. So this command, the GPIO set as peripheral module function output pins. So what we are doing is we are setting pins 2 and 3 on port 1 as output pins. So basically, we are going to use this program to relay our stuff onto the serial terminal. And that's why we are using the output pin. Let's say we need to do a bidirectional code wherein we also feed data to the board from our terminal. Then we also need to set these pins as input pins, like bidirectional stuff. And then another important part of this is setting the clock frequency to 12. Actually, it's not exactly 12, but we set the DCO-centered frequency to 12 megahertz. This frequency is actually then used to control our clock frequency. It's more of like multiplexing. We'll come to this as I explain about this object. So again, here, the USCI UART config. This is the object which we are defining, and UART config is like an instance of that object. And then this has various different parameters. So first we define the clock source, and here we define that we need it as the on-chip clock for UART communication. And then we need to set these values, which are called prescaler value and the UCBRX SX register value. So all the other things are more like based on your application, like how many least significant bits it has, what is the UART mode, if it has oversampling, if we need parity or if we don't need parity. So, oops. So if we need parity or if we don't need parity. So all of this can be changed as per our application, but right now we are setting it to a 9600 baud rate with 8 data bits, no parity, and 1 stop bit. Now, how do we define what should be our baud rate? Because you don't see 9600 being put directly anywhere over here. So for this, we need to look at this formula. So in this, your baud rate is nothing but your clock source frequency divided by prescaler into number of clock cycles per bit. Now we have our communication set to 8 data bits. And then we have our first modulation stage, that is the UCBR set to 2. What that means is that we are going to have 16 samples per clock cycle. Sorry, we are going to have 16 clock cycles per bit. My bad. I think I just said it reverse. So this number is nothing but 16, and we get it as 16 because it is 8 into 2. That is the value of that register. Now, that's why the DCO frequency is important, because the clock source frequency is half of the DCO source frequency. Since we set that as 12, we get the clock source frequency as 6. And then finally, if we plug all of these values in the baud rate, we get 6 megahertz divided by 78 into 16, which is roughly 9615 or something. So essentially, this is how we set baud rate for this module. If you need any other baud rates, then you can change the DCO frequency. But the DCO frequency is actually always supposed to be kept to 12. I mean, that's what's always advised as a good practice. So you can change the prescaler values if you need to change the baud rate. That's the usual convention when it goes to changing baud rates. And so this was all about initializing this module. And then there's this function which initializes this module. Here we are just setting the values. Here we are initializing this, like the UART module, which is the USCI module. And then we are setting these values to that particular module. So now we are ready with the module that's going to start our communication. And then the enable module is just a simple command that kind of tells the board that, okay, start. You need to enable this module because soon communication is going to start on it. And now we jump into void main. We first stop the watchdog timers and any other interrupts that might cause any problems. And then we call the UART init. All of the above code that I explained is a part of UART init. So before any of your communication starts, all of this setup is already going to be done in place. And now care message is the message that you need to send to the serial terminal. Here we are going to use the most popular one, which is hello world. And then the below program is just a variation of how you can pass every character individually to the UART module. So this is just a for loop that runs until you reach the end of the string. And UART transmit data is what you use to invoke the UART module and send your data, which is message of I, which is going to be H, E, L, L, O, and so on, to the UART module, and it's going to transmit it on to the serial terminal. And then we are just transmitting a \n, because if, let's say, we transmit it again, so it just goes on to the next line. This is just for cleanliness, I'll say. And until this is going on, we just have a while one, which has the __ WFI. This is nothing but wait for interrupt. It's actually a function specific to MSP432 called deep sleep, and it's especially used for like energy conservation, or it's responsible for low energy consumption of the board. Okay, now this was about the program. Now let's compile the program. I'd already compiled it before. So it's gonna be done very fast. Yeah, that's done. We get the binary file, and now I run the debugger. Yeah, it might take some time. In the meanwhile, we set up our terminal. So I've already set it, but in case you need to set it, you need to go to Device Manager first, and then check which is the COM port to which communication needs to be started. So in this case, it is COM10, because XDS110 is our debugger class. And so COM10 is where you expect your communication to reach. And so you go to this place, which is open a terminal, and then you place this as COM10 baud rate 9600, everything which we use to set up our module. And so I'm not going to say okay, because I've already set everything here. So I'm just going to say canceled. Okay, and now it's burnt on the board. So let's run the program. Yep, there you go. You get a hello world on the COM port. Since this is not inside the while one loop, this is just going to be printed once, but lines 56 to 59 can be pasted inside a while one loop, and then you're just gonna have the board printing endlessly hello world, hello world, hello world to that serial terminal. So this was about the UART program. This is the most simplistic approach that which we can take to printing stuff on the serial terminal, and so you can use this to print any value which you obtain throughout the runtime of the program to post it into the serial terminal. And in the next videos, this is going to be important for us whenever we need to check any value that comes on, like comes in the program, which we want to read from the COM port. So that was all for today's video. So this was, oops. So that was all for today's video, and that was all for today's video, and then this was all about UART. In the next videos, we'll be looking at some crypto algorithms, which we would be using as benchmarks to see their
Yeah.
computational runtime. So yeah, thank you.
Yeah. Thank you, Rohit.
Thank you, Rohit.